Let's go back to our original example where we talked about which professor gives or provides the best grades for students, or which professor has students that get the best grades in class. What you'll notice on the screen here is I've already, under median there, I've listed off all of the grades that we saw earlier from least to greatest, which is going to really help us with our median, and it's very important that we have them in least to greatest as well. But the first thing we want to do is we want to find what is the mean of both of these professors. Okay, so we're going to try to solve for what is the mean, which is one of the ways of measuring central tendency, or one of the ways of measuring average. All three of these measure average in a certain way. Okay, we often talk about mean as the average, but they all measure average in their own way. So let's measure the mean. Okay, the mean, and because we have we're going to consider this to be all data. Actually, you know what? It's not. We're going to measure it as x bar here is equal to the sum of all of our data points. Okay, so that means that we're going to be using our sum of, okay, x over n. And when we do this here, if we add all of these together, so I'm going to do this for us just a little bit quicker. If we add them all together, we get 1290, and there are 20 of them, so we divide by 20. Okay, so again, this is the way that we would solve for our average. I'm going to quickly put in my summation sign there. All right, summation. Okay, so the sum, we add them all together, and you can do this on your calculator. You don't need to do it in your head. You can definitely do it on a calculator. We get 1,290. We divide by 20. And when we solve for it, we're going to get x bar is going to equal to 54.5%. Okay. So if we were to take these scores, let's imagine that there was 20 people in the class, and these are scores you got on your test. The average score on the test, from what I would say, would be 64.5%. Okay, and that's pretty common. That's often the way that we would measure the average. Okay, I'm not saying 64.5% is common as an average. I'm saying that this is how we would usually do it. Okay, so this is how I would normally measure average. So if in class I were to tell you that the average was 64.5%, this is exactly how I calculate it. Okay, I take all the scores and I divide by the number of scores that there are. Let's do the same thing for Professor Rosenthal. Okay, Professor Rosenthal, again, it's x sum of x over n. And if we add all of his together, we get 1,225, and there's also 20. So we're going to divide by 20. And again, I'm going to quickly put in my summation sign right there so that we can see what it is. All right, now, if we do this one, you'll notice that 1,225 is less than 1,290, so it's probably going to be a lower average because Professor Rosenthal is the worst teacher. No, I'm joking. That's not necessarily the truth. Okay, our average here is 61.25%. So if you look at this here, you're going to say, Professor Jacobs' students usually get a better average. Okay, meaning that you in Professor Jacobs' class would probably get a better average. Is that always the truth? Well, let's take a look at the median. Okay, the median is our middle number. We have 20 of them, so that means that the middle is going to be right between the 10th and 11th terms. The 10th one is 65, the 11th one is 65. The average of those two, or right in between, is 65. So that means that our median is equal to 65%, okay, at least for Professor Jacobs. Professor Rosenthal, on the other hand, okay, again, between the 10th and the 11th term, and I've broken them up exactly that way on purpose, 75 is the 10th term, 75 is the 11th term, meaning that in Professor Rosenthal's class, 75 is our median or our average. Okay? So in this case here, Professor Rosenthal's students, majority of them are actually higher than, or half of his students get above 75, whereas only in Professor Jacobs, half of his students only get above 65%. that tells us that Professor Rosenthal's students tend to do better. And maybe that would be clued in by all the students that got 100 in the 90s with Professor Rosenthal, whereas with Jacobs, most of them kind of get in between. They kind of get between 60s and 70s. Okay, so that's where there is a big change, and that's something to take a look at. This is another way of representing average. Okay, the median is a way of representing average, and depending on what we want to skew, we can choose one or the other. If I were trying to promote Professor Jacobs' class, I would say that the mean was 64.5%, which is like over 3% better than Professor Rosenthal's class. Whereas if I was trying to promote Professor Rosenthal's class, I would be choosing that 75, that median, saying that most, on average, more students get better than, or half the students get better than 75% in his class compared to Professor Jacobs. That's exactly what we would be doing if we were to try to promote certain things. And that's why data can really skew the way that we look at certain things. Mode, most common. So we have 75 3 times. So the mode for Professor Jacobs is 75%. Okay. Whereas Professor Rosenthal, 80 is there 3 times, and so is 75. So it would be between 75 and 80%. So that would actually be both of them. It'd be 75 or 80%. There we go. Okay, so 75 or 80%. Okay. So this is the way of measuring our different data. These are pretty much the same, so that's not really going to be something as a talking point, but we can still determine which is, or what the mode is. Again, it's the most common. And if there's more than one place that has the same number, that's the most common, we choose both of them or all of them. All right, what does this tell us about each professor's teaching ability? Well, the way that I'm going to look at it here, okay, Professor Jacobs students all get around the same mark. The students in Professor Rosenthal's class either get really high marks, make sure to spell that correctly, or do extremely poorly. So this is what we could say from it. Okay, we can use mean and median. Okay, Professor Jacobs get a higher mean, Professor Rosenthal gets a higher median. Okay? And again, it's just showing that in this case here, Professor Jacobs has a very close average, okay, very tight-knit values, and Professor Rosenthal is much more spread apart. Okay? And that's one of the things that we can take a look at in how to represent data and how we represent a mean or a median. Sorry, how we represent an average based on mean or median.